Bismillahirrahmanirrahim. Assalamualaikum and a very good day to all of you. I'm Mardiana Liza Osman from University Malaysia Perlis. Today, I will present about our research project entitled Performance of Ceramic Insulator under the Effect of Contaminated Condition. The co-author of this paper is Aini Natasha, Amin Nazifah, Khairul Anwar, Ahmad Zaidi, Nurul Azmi, and Rizda Fitri Kurnia. This is the outline of presentation. First, I will explain about high voltage insulators, followed by problem statement, methodology, result analysis, and last but not least is conclusion. For the introduction, electricity produced by a generator in power plant, then it will transmit over long distance to consumers through the transmission line. Overhead line is kept in the middle of the air and connected to the transmission tower to provide necessary minimum ground clearance based on the overhead line voltage level. The overhead conductor must be electrically disconnected from the ground potential of the transmission tower. The equipment that performs the dual task mentioned is known as a transmission line insulator or simply an insulator. This is high voltage insulator group. In this research, ceramic insulator such as glass and porcelain was used because it is widely used in high voltage transmission lines due to its high mechanical strength, performing well on heat and aging resistance. For the problem statement, from previous studies, most of researchers found that outdoor environmental exposure contribute to ceramic insulator degradation due to chemical change from dry band arcing and environmental. This contaminant allow electric field distribution of the insulator to become unstable, which act as a non-linear or highly variable resistor. Thus, a path of leakage current is created and heat is generated until a flashover is caused. For the methodology, in this paper, simulation work was used to investigate the performance of insulated string with the effect of contamination under the dry condition on 33 kV high voltage. The 2D CAD model of 4-unit suspension porcelain and glass insulator has import into the finite element method software, which is COMSOL Multiphysics. The dimensions of each insulator are tabulated in Table 1. And for Table 2 is for transmission level of contamination level of insulators, which is no contamination is 0 millimeter, light is 1 millimeter, medium is 1.5 millimeter, and heavy is 2 millimeter. Okay, this is for methodology. Okay, finite element analysis divide the model into an equivalent system of many small elements that share common point called nodes. The elements can be of any shape fit together to form a mesh of the systems. All blocks included in the modeling must be meshed and labeled with related properties. The mesh density is based on the mesh spacing value that are either user specified or automatically calculated. Figure 6 shows the building mesh of the model string insulator in clean condition used in this research. It is worth emphasizing that the number of mesh and nodes depend on the insulator modeling. Thus, clean and contaminated insulator have different mesh and nodes. Okay, this is the result of electrical potential of insulator under clean condition. Okay. It was observed that voltage distribution along the insulator string's surface is non-uniform due to stray capacitance. The maximum voltage was attained at the insulator pin of high voltage line conductor of insulator 4, represented by a red color. However, the minimum voltage was attained at the insulator cap of insulator 1, represented by blue color. As the distance of insulator unit to ground of the string decrease, the voltage distribution over unit also decrease. The voltage distribution of an insulator closer to the high voltage line connector was reduced 38.79% from 33 kV to 20.2 kV by decreasing the insulator unit's distance from insulator 3 to insulator 2. In contrast, when approaching the insulator cap of insulator 2, the voltage distribution dropped to 13.3 kV. This is because the insulator's bottom end was frequently high voltage level conductor in transmission line tower, while the insulator's top end was the ground. Okay. Now we move to voltage distribution along the contaminated porcelain and glass insulator. Okay, the voltage distribution was computed along three-pitch distance of uniform contaminated insulator, and it was noticed that the voltage distribution followed similar trends with the clean ceramic insulator, such as glass and porcelain insulator, but small difference can be seen visually. Now we move to electric field of insulator under clean condition. Okay. This shows the electric field that is more concentrated on the part of the cement and ceramic shell inside the metal cap of insulator string can be detected. Since this is a 4-unit ceramic insulator, hence 3 obvious electric field peaks exist, and each peak represents one porcelain insulator unit. Each sharp rise of the electric field represents the point where the cement and metal intersect. The highest electric field of ceramic insulator string is insulator 4, which is glass insulator, 650 kilovolt per meter. Now we move to result of electric field along the contaminated porcelain and glass insulator. In this section, a thin layer of contamination is added on the 4-unit ceramic insulator surface to investigate the effect of contamination on the electric field distribution of insulator string. For each insulator in the insulator string, it can be found that the electric field strength exists at the bottom pin and the point where the ceramic and cement meet inside the cap of the insulator. The electric field is greatest near to pin of insulator 4 and decrease gradually when moving outward. The highest electric field is contaminated glass with 800 kilovolt per meter. Okay, for the conclusion, uniform contamination improve the voltage distribution compared with the of the clean case for power frequency voltage. But the value of electric field decreased by about 2 times than that of the clean condition. The linearization of the voltage distribution displays higher potential toward the center of the insulator, and this, together with the fact that the insulator surface is conducting, result in high field strength near the section with a small radius of curvature, thus may be initiating corona. Okay, that's all from me. Thank you.